This is part 2 of me having a go at the almost impossible chessboard puzzle.
If you like my videos, feel free to do nothing. Just grab a cup of coffee
and enjoy.
Since yesterday, I think I figured out a way of using one coin flip to actually encode 3 bits of information. We can let the first bit be defined by the parity of the diagonal. So we arrange so that prisoner number 2 checks the parity of the diagonal, and that odd or even parity defines bit number 1. Bit number 2 can be the frame of this rectangle. So all this frame here, the parity of this is B2. And then bit number 3 we can define as the parity of this rectangle here, this area here. That's bit number 3. Let's see what we have encoded using these areas. So in this case, bit number 1 is the parity of the diagonal, and we define parity as even or odd heads. Then we get 1, 2, 3, 4. So we have an even, let's call that a 0, an even parity of B1. B2 is the frame, the blue framing here, and we have 1, 2, 3, 4, 5. So this is odd. And B3 is 1, 2, 3, 4. It's even. Now let's try to encode a number. So let's say we want to encode the inverse. So we want to convey that message to prisoner number 2. You can see that if we flip this one, then the parity of the red will change, the parity of the blue will change, and the parity of the green will change. So this position will encode this number given this board. So let's check if all these flipping patterns is possible using only one coin flip with these defined colored areas. So if we want to have a 0, 0, 0 flipping pattern, we can just flip this coin, because then neither the red, green or blue area are affected. If we want to have flipping pattern number 1, we can flip this coin, because then only the green is affected, because it's outside the blue and red. And flipping pattern number 2, we want to flip only the blue pattern, and then we can flip this coin, because this is inside blue but outside red and green. And so on. I've gone through this table, and fingers crossed, if I made everything correct, I have discovered that 0, 1, 2, 3, 4, 5, 6 and 7 is possible to encode with these fixed patterns. Question now becomes, can I use this way of thinking and define a 4th pattern that overlays on this in such a way that I can find a way to place a coin flip and have any combination of the 4 areas covered or not. Let's assume there is a purple area somewhere here, or a pattern that enables us to encode these flipping patterns. My intuition tells me that a purple area should be some form of raster here. So if we, for example, say that we define this one on the first row, and then take this to be purple and this to be purple on the second one, then this to be purple and this to be purple on the third row, and this to be purple and this to be purple on the 4th row. So how far do we get with this setup? Let's check the purple addition here. So purple 0 is outside every color, and we can find one here, of course. So this we can say is purple 0. Purple 1, we're only in the purple color, none of the others, would be this one. and purple 2 only in the green could be that's not possible. What if I say that it's the odd rows that are the purple areas? I don't think it's enough, but just to get a feeling of what's going on here. Okay, I'll stop here for now because this is as far as I've been thinking about this today. But at least it seems promising. I've discovered that I can transform this single flip coin problem into overlapping areas. If I define areas that overlap in such a way that I can always find a position where none, 1, 2, 3, or 4, or however patterns there are, will be affected, then I can actually, by selecting which coin to flip, encode any of the flipping patterns defined by the overlaps. So question now is, how far can I stretch this? How many patterns can I fit on this board so that a single coin flip can encode 3, 4 or up to 5 bit patterns? Correction, I need 6 bits, of course. With 6 bits I can encode 0 to 63, which then I can use to indicate where the key is. Good luck solving this puzzle. I haven't solved it yet, but thank you for watching and see you next time.
If you like my videos, feel free to do nothing. Just grab a cup of coffee
and enjoy.